Hello, welcome to our second section of this matter chapter, and this is all about classifications of matter. So yesterday we focused on more of the physical property side and what that looks like within matter, and we focused on the three states of matter. Now today we're going to talk about classifying, and in class I am going to help you make a concept web, so hopefully this stuff can be a little bit more organized and we understand what we're doing. Some things that I want you to think about before we even start talking is the concept of like a pure substance. And maybe you don't know that exact word, but you've probably heard of compounds and you've probably heard of elements. And these are two examples of pure substances. They are complete. They have an exact number of something that makes them that pure substance. We are going to compare this concept to the idea of mixtures. And so it may get a little bit dicey. Hopefully I can walk you through this easily. After this video, you should be able to define a mixture and distinguish the difference between a pure substance. So kind of what I just talked about in the previous slide. You should distinguish between a heterogeneous and homogeneous mixture, distinguish between elements and compounds, so understand the difference between the two, and then describe how to separate mixtures. All right, so let's jump into this bad boy. So in chemistry, matter can be categorized in two different ways. You can have pure substances and you can have mixtures. So we're going to talk about mixtures first. A mixture is a physical blend of two or more components. That means that physically these two things, oh bless you, my dog just sneezed. But anyway, you can have two things and physically mix them together. So for example, water is a compound, but when it's found in a river, it's physically moving by gravity and the flow of the river, and so then it comes into contact with other particular substances that mix all together, and that is a physical mixture. Each component holds its own identity, so two or more components together, each of those components still hold their true identity. So for example, salt water. I mix salt into water, and if you use enough salt, it completely disintegrates into, I guess I shouldn't say disintegrates, but it flows into the water and you almost can't tell that there's salt in it. So it's not a saturated solution yet. And the reason you know that there's salt in there is that one, you can taste the salt. So the salt still holds its own properties, and so does the water. You can easily remove the salt by boiling out the water and you still have the component of salt. Okay, so that is a big difference when it comes to mixtures. A lot of times these mixtures can be physically, these components can be physically removed from one another very easily or through specific kinds of tests. There are two different types of mixtures. You have homogeneous and heterogeneous. A homogeneous mixture is when the composition is uniform throughout the mixture. And so what I mean by that is if I have a glass of milk, and I pour 1 scoop of cocoa powder into it, I now have chocolate milk. If I take another glass of milk and I put 2 scoops of of cocoa powder into it, again, we have chocolate milk. A little more chocolatey. But the thing is, with that, it's all the same throughout. So it's really hard to tell whether or not that mixture is not a pure substance or not. And the same can be said the opposite can be said for a heterogeneous mixture. It's a mixture in which the composition is not uniform throughout the mixture. So these are a lot more apparent and easy to see. Vegetable soup is a good example of a heterogeneous mixture. Any spoonful of that soup, it contains different amounts of something. So you could have all beans in one of your spoonfuls and then all vegetables in another spoonful. That's the big difference between heterogeneous and homogeneous. Heterogeneous, generally you can pick out. Homogeneous, a lot harder to separate, but still two different components. So a good question that I've gotten before is, well, how do you separate a mixture, especially how do you separate a homogeneous mixture? So for example, if I were to mix maybe like, I don't know, sand and some other kind of component, how do you easily remove the sand? Well, it's not really done easily, but there are two techniques, and we are going to do these two techniques in the lab at some point. Filtration more especially. So filtration is a technique that separates solids from liquids in a heterogeneous mixture, right? If I have sand and water, I pour the sand water mixture into a filter, the sand's going to sit at the top of the filter in comparison to the water that's going to flow through that filter. Very easily, we've probably all done this with like a strainer, same concept. Distillation is a method of separating a mixture based on differences and boiling points. This is a huge thing in chemistry. A lot of, or pretty much every single compound has a different boiling point, so you can easily boil off something else, allowing it to distill into a different container. And I do have a picture that I am going to show you on what this looks like in the lab. There are other ways that you can separate mixtures, but these are the two we're probably going to use solely in our class. If you progress onto a more advanced chemistry, you will see that there are a number of ways to separate mixtures. All right, so remember I talked about breaking down matter into two different categories. We have mixtures, and we can break that down even further into homogeneous and heterogeneous. And then we can also break down matter into pure substances. And pure substances can also be broken down into elements and compounds. So I know it's a lot to organize in your mind. I will give you a concept map, and we'll do this together to help you organize these thoughts. So an element is the simplest form of matter that has a unique set of properties. So it cannot be broken down, and it cannot be converted into another element. Think of old scientists. We talked about alchemists. Remember, they would try to make lead into gold. This is absolutely impossible because of the fact that each element holds its own set of properties to create that identity. It has a specific set of atoms, specific set of electrons, and a specific set of neutrons and protons. And this is what defines that element. It makes it into that specific element with its own properties. So that's one type of pure substance. The second type of pure substances are compounds. And these are pure substances containing two or more elements. So anytime you have two or more elements that have been chemically combined in a fixed proportion, this is known as a compound. So like even if you have two hydrogen atoms and they're bonded together, they're chemically bonded together, that makes that a compound. These cannot be physically separated or changed. So you can't easily say, oh, look, I have two hydrogen atoms and one oxygen atom together. I'm just going to pull them apart and no longer have water. That's not how it works. They have to be chemically changed in order to separate them. And what that means is you have to do some kind of permanent change to them. And so the very last thing I want to talk about, because I think this is going to be the most difficult concept, or I guess not difficult, but more, it's just hard. Visually, it's harder to distinguish between some pure substances and mixtures, especially homogeneous mixtures. Because if you look at something like gasoline, you're like, yeah, that's all uniform. That looks the same, so that's got to be a pure substance. Well, no, it's actually a mixture because it's a combination of different substances. And we know that because we can get different grades of gas at the gas station, right? And that's how you pay more money, is the different grades, the better quality, if you will. Pure substances cannot be physically changed or altered. They have a set of numbers or a set of things that make them what they are. So for example, if I have two hydrogen and one oxygen atom combined by hydrogen bond, that gives me a water molecule or a water compound. Okay, if I have two hydrogen and two oxygen atoms together, that gives me hydrogen peroxide. Still the same stuff, but it gives me two different compounds. In comparison to if I have a mixture, and like I said, my old example of the chocolate milk, I still have chocolate milk whether I put 2 scoops of cocoa in it or 1 scoop of cocoa. So think of pure substances as having a set number of something. Mixtures, you can really just change the number, and if it looks all the same throughout, homogeneous. If you can pick it apart, heterogeneous. Biggest thing, mixtures can be physically separated. Pure substances cannot. If you have any questions, please ask me on Edpuzzle. I realize this was rushed. You probably heard my kids screaming in the background because, why would I make a video without children screaming in the background? Again, ask me any questions you can on Edpuzzle. I am more than willing to help you, and I will be giving a lot of examples in class when we talk about this. So don't trip, Chip, if you don't get it.